Welcome to this video. We're going to be looking at sizing conduit in this one, and then be sure to check out the next video, which will be filling the conduit. The difference is with sizing conduit, we're going to be looking at different conductors, different amounts of conductors and different types, and we're going to be looking at if we have an actual set number of those. We have 5 of these, 3 of these, 2 of those, and what size conduit is going to be appropriate for those wires. We're going to start simple and then get into something more complex. And then we're going to get into the next video, which is going to be filling the conduit, which is going to say, okay, so if I have this type of wire, how many of those can I fit in this size of conduit? So it's in a similar train of thought, but it's coming from a different angle. And with this, it's going to start simple, where we're going to have a certain wire type and certain gauge wire, and we're going to say how many of those can we fit in a certain size conduit. Then we're going to get into more complex ones that'll say, okay, we already have, let's say, 3 10 gauge XHHW, 4 14 gauge THHN, and let's just say you had a 4-inch PVC. How many more 8 gauge THHN conductors could you fit in there? So we're going to look at stuff like that, which will be very useful in real life, but you will also be tested on as well. We're going to be using the National Electrical Code Book. This is going to be applicable for 2017, 2020, and 2023. I will be using the 2020 version, but these have not changed. So make sure you are familiar with Chapter 9 of the NEC Codebook. If you're not, I do have a video I will link in the description, which will give a brief overview of certain key points found in the chapter, as well as the main tables that you're going to want to use, as well as another table that isn't in Chapter 9, but is going to tie into everything and be very useful. Okay, so we're going to get into the first question. I will explain as I go, and this will be the quickest way to learn this. So we see we have 3 750 kc mil XHHW aluminum. You do see the KCM, XHHW, and the aluminum, how they're going down with the arrow, and that's just showing that all 3 of these have the kc mil, XHHW, and aluminum. This is a quicker way to write this down, so this might be a good tip for you when you're taking a test. It also can be more efficient to read because you know for sure that all 3 of these are the same. There's some very similar wire types, so you're not going to have to double check that it's THN and THWN if you use this method when you have the same wire type. We do see different amounts of wire in different gauges. So what we're going to do is going to Chapter 9, Table 5, and we're simply going to look for our wire type in the first left column here. We're looking for XHHW. For reference, if you go to the first page of Table 5 in Chapter 9 here, you're going to flip one page and you're going to look at the right page and you will see XHHW. You will also see it on the left-hand page right before this, but those are going to be smaller gauges of wire. Okay, so we're going to be looking for first the 750. And we're going to be looking for the square inches, or where it says inches with the small 2. Okay, we see I'm staying in the same order. I have 3 times the wire size for 750 kc mil, which is now going to be 3 times 1.053. I like to just stay in one train of thought, so now I'm going to go back to the table exactly where I was, XHHW, and I'm going to look for now where it says 500 kc mil. Again, I'm going to go over to the square inches and I'm going to see 0.6984, and I'm going to add that to the rest. I'm going to go back to the table now. I'm looking for 250 kc mil, and I see the number 0.3904. Okay, now I'm going to add that all together, but first I should have put 1.0532 to get the exact number. So now 3 times 1.0532 equals 3.1596. Now we're going to add that to the 0.6984 and the 0.3904. And we're going to get the answer 4.2484 inches squared. So now I wanted to make this not very intimidating for the first problem. So now we're going to look at the second part of the problem. I found that a lot of times when you break a lesson up and then you combine the lessons, it can make it easier. So here's the second part of this question where it's asking the type of conduit that we're going to be putting this in. Now that we already have the size figured out, what trade size are we going to be able to use when we're thinking about Schedule 80 PVC and Schedule 40 PVC? And this is simple. We just go to the table before this. We're on Table 5 in Chapter 9 right now. So now we're just going to go to Table 4 of Chapter 9. And here we're going to find the specific type of conduit that we're looking at. So if you look at the first page of Table 4, if you flip a page and you look at the bottom of the left-hand page, you see Schedule 80 PVC, And if you look at the top of the right-hand page, you see the Schedule 40 PVC. We see the metric designator, the trade size, and we see the over 2 wire section. So what we're going to be looking at is the over 2 wire section because we're working with over 2 wires here. Of course, if you're using 2 wires or only 1 wire, you'd use those tables that accommodate that. And if you're using a piece of conduit under 24 inches or a conduit nipple under 24 inches, that's where you use that 60% column. They also might ask you about total area, so that's where you have the total area 100%. So again, we're looking at the over 2 wires 40% section here with the Schedule 80 PVC, and we want to find 4.2484, and that is in the inches square, of course, and we see 3.475, so we're always going to be upsizing, and we see the next size is 4.503, so that's bigger than what we're looking at, and that's perfect because now we have a little extra room and this will all fit in there perfectly fine. We see that the 4.503, when we look over to the left, is the trade size 4, which will be 4 inches. So they might have it labeled as trade size 4, or they might just have it labeled as 4-inch PVC Schedule 80 conduit. Okay, now similarly, now we're going to look at the table for the Schedule 40 PVC. Same thing, we're going to look for that number 4.2484, and we see here that we have a 5.022, which is going to be the size that will work with this. And if we look over to the left, we see trade size 4 again, so 4-inch conduit. This time the Schedule 40. Okay, now since this is just the first question, just a recap of what we did. We had 3 750 KC mil XHHW aluminum wires, and in fact we didn't pay attention to aluminum. So that's the thing, is that we already have the wire type, the XHHW. Aluminum and copper does matter when you're thinking about ampacity, but when you're thinking about wire size, you're going to have the same size wire as a gauge. It's American wire gauge, so it's going to be still the same size, but it's going to be rated differently for ampacity and also for the type of insulation, which we already see here. We already know the type of insulation because we have the XHHW wire type. And in fact, your different types of insulation have to do with the ampacity table, which has to do with not melting the insulation. How much current can you run through this wire without the insulation getting damaged through the process of using the wire? So now we know copper and aluminum is irrelevant because we already know the wire type. And we know we just use table 5 in chapter 9 to find the separate square inches of each of the wires. Add them all together. Of course, we have to accommodate when we have 3 of them. And then from there, we have the total size of them put together. And then now we're thinking, okay, what size of certain conduit will be able to accommodate all of these wires that we have now that we know how much space it's going to take up. And just for space, I'm not writing this down at the moment, but we're going to be fitting this into Schedule 40 PVC, EMT, rigid metal conduit, or RMC, and steel flex. Okay, so with this question, we have the bare conductor. So we have 3 400 kcm THWN copper, and then we have 1 300 kcm THWN copper, and 1 3/0 bare conductor. Okay, so we're going to go over here to table 5. We're going to find THWN in the correct size we're looking for. We're looking for 400 kcm first. Okay, so for the 400 kcm THWN, we see 0.5863, and of course we have 3 of those. And then for the 300 kcm, we see 0.4608. Now I mentioned this in the chapter 9 video linked below, and that is that if you have a bare conductor, you want to go to table 8 here in chapter 9. From here, you're going to want to go to where it says overall area and find the square inches. Okay, and there we get 0.173. Now first, we're going to have to take the 0.5863 and multiply it by 3. That's going to give us 1.7589. We're going to add that to the 0.4608 and the 0.173. That's going to give us 2.3927 square inches. Now that we have the total size for everything, we're going to fit that into EMT, Schedule 40 PVC, and RMC. For this, we're going to go back into table 4, and we're going to see that the first table is EMT. We're going to look for that 2.3927 number, and we see 2.343, but that's why it's good to write all of those decimal points, because sometimes you will get very close. And in fact, we're going to have to go to the 3.538 now. That's going to give us the trade size 3 for EMT. Now we're going to flip the page, we're going to find schedule 40 PVC, and we're going to look for that same number. And we see a 2.907, and that is the trade size 3. Next, we're going to look at RMC using the same number, and we see a 3.000, and that is the trade size 3. So we can see these are all trade size 3. And also, if we're looking at that steel flex, we see flexible metal conduit. We see a 2.827 with a trade size 3. Okay, next question. We have 4 350 KC mil compact stranded aluminum conductors and 1 250 KC mil THHN compact stranded aluminum conductor. We're going to fit this into schedule 40 PVC and EMT. Okay, so first of all, we have the compact stranded aluminum, something we haven't worked with yet, but all you're going to have to do is flip over a few pages and go to table 5A of chapter 9, which is going to be your compact copper and aluminum building wire, nominal dimensions, and areas. Okay, so we're going to be looking for the size AWG or KC mil. In this case, we have the 350 KC mil we're going to be looking at first, and it is THHN. So you'll see where it has the different types. So find type THHN, and of course we want to find the approximate area, so we have the inches squared. That's going to give us 0.4656, and we have 4 of those, so 4 times. Then again, we're looking at table 5A, and we're going to look at 250 KC mil now, and we're going to look at the type THHN conductor. Under the approximate area, we see 0.3525. 0.4656 times 4 gives us 1.8624. We're going to add that to the 0.3525. That gives us 2.2149, and of course all this is inches squared. Now that we have that total number, we're going to try to fit that in the schedule 40 PVC and the EMT. Again, we just go to table 4 in chapter 9, and EMT is the very first one, so I'll just start with EMT. We're looking for 2.2149, and I see 2.343. And that is a 2.5-inch trade size. Now, same thing, I'm using the same number, and I'm looking at schedule 40 PVC now, and I see a 2.907, and that's a 3-inch trade size. Okay, now we know the table for the compact stranded copper and aluminum wires. Okay, next question, we're looking at 6 3/0 THHN aluminum wires. We're going to fit this in EMT, FMC, IMC, ENT, and LNFCA, which sounds kind of crazy, but that's just liquid, flexible, non-metallic conduit, type A. So now we have yet again another table to use. We're going to go into Annex C. This is not in Chapter 9, but this is found after it. When we go to Annex C, we're going to want to look at the very first page where it says Informative Annex C, Conduit Tubing, and we're going to want to see that it lists all of the pages for the separate types of conduit. This is very important because this is a very big section of the book, and you can see there's quite a big gap in between some of these. So you're going to want to go back to this very first page when, let's say, you're looking at PVC, or even when you're looking at RMC, because as you can see, that's further down from the beginning, and you're going to be flipping a bunch of pages instead of just going here and finding the exact page to go to. Okay, so remember the first page of Annex C is very important. The first page of Chapter 9 is also very informative. We're going to go into Annex C now, and we're going to keep in mind that we're going to look for specific types of conduit. First, we're going to look at EMT, and now we're going to see this is a little different of a table. So Annex C tells us if we have a wire that has the same gauge and the same wire type, how many of those wires can fit in a certain size conduit. So we're looking at 6 3/0 THHN aluminum. They're all 3/0 THHN aluminum, and we have 6 of them. So of course we're looking under EMT, we're then going to look for THHN, and then we're going to find 3/0, and we're going to look for the number 6. We see the number 5, and we see the number 8. So again, we're always going to size up and not down. We're going to choose 8. And with 8, you see above that, we have 2.5 trade size. Okay, and of course, we can use this table backwards. If they didn't tell us how many of the conductors we had, but we had all the same type of conductors, and we had a certain size conduit. So if they said, okay, we have a 2.5-inch conduit, how many 3/0 THHN aluminum conductors can we fit in that? Since they're just asking about all the same type of conductors, you can use the table backwards. You look for THHN, of course, in EMT, and you can look for the 2.5-inch, and then you line that up with the 3/0, because we know that we have 3/0, we know the wire size, we know the conductor size, and then we just see where that all lines up. And we see that lines up with the 8 conductors. So for the answer for that question, we would be able to put 8 3/0 THHN aluminum conductors in here. Okay, I'll stick to the question, but I just like to throw in some good information in here. Next, we're looking at FMC. So again, before flipping through a bunch of pages, go back to that first page, look for FMC, and we'll see it lists it as page 742. So now we're in the FMC table, and now we're just going to look for THHN 3/0, and we're going to look for the number 6. Again, we don't see the number 6, we see 5, and we see 7. So again, we're going to choose the number that is rounded up, the 7. So we have 2.5 inches. Next, we're looking for IMC. Again, we're going back to that first page. We see IMC is first listed on page 748. And again, we're looking for THHN 3/0 and then the number 6. We see the number 7 and we see 2.5 inches. Or in other words, 2.5 inch trade size. Okay, now this is where things are going to get a little bit interesting. I don't know if they would ask you a question like this on a test, but this is more real life information here. We're now going to be looking for ENT. We see that ENT starts on page 736. We find THHN 3/0 and we look for the number 6. And we see it stops at the number 5. So it has blanks after that. And that is because the largest size of ENT is your 2 inch. So they're not going to have a bigger size. And because of that, you're not going to be able to fit 6 3/0 THHN aluminum conductors inside of your ENT, but you can see that you will be able to fit 5. And then similarly, we'll look at the LNFCA. This starts on page 754 and 3/0, and again, we see it stops at 5. Okay, so same thing, it stops at 2 inch, so we would not be able to use the type LFNCA for 6 3/0 THHN aluminum conductors. So that's just something that is good to know. Okay, next question. We see 10 14 gauge THHN conductors, 3 1/0 RHW conductors, and 1 number 8 THW conductor. We want to fit this into EMT, Schedule 40 PVC, and RMC. You see now we are working with different wire types. So first here in chapter 9, we're going to look at table 5. We see THHN and we're looking for 14 gauge. We see that it's 0.0097 square inches. And of course that is going to be times 10 for the 14 gauge. Now we're looking for RHW and we're looking for 1/0. And that's on the same page but right above it, here in the 2020 edition at least. So I'm looking at RHW, I see 1/0 and I see 0.2223. Okay, now we're going to look for THW and we're going to look for the 8 gauge. And we see that on the same page here in the same location, we have the RHW we were just looking at, but we also have the THW. And we don't see 8 gauge here, but we see right above that there's the number 8. But if we look to the left of that, that is only including the RHH, RHW, and RHW2 type wires. So in fact, we're actually going to have to go over to the left page here. And we do see that we have THW 8 gauge. And where we see it here, it is 0.0437 square inches. We're going to get 0.0097 times 10. We're going to get 0.097. We're going to get 0.2223 times 3. And we're going to get 0.6669. And we're going to add all that together to 0.0437 as well. And we're going to get the total sum, 0.8076 square inches. Now we're going to try to fit that in the EMT, Schedule 40 PVC, and the RMC. Okay, so I got this number down because I'm going to get in the way of it right now. First, I'm going to be looking at EMT. I see 0.814, and that works because I have 0.807. That'll give me a 1.5 inch piece of EMT. Now I'm going to be looking at Schedule 40 PVC, still here in Table 4, and I see a 1.316, which is a 2 inch trade size. And now I'm just going to be looking at RMC, and I see a 0.829, and we see that is a 1.5 inch RMC conduit. Okay, so that's it for this video. Make sure to check out the conduit fill, or formerly sometimes known as pipe fill calculations. That'll be another great video, and that will basically be the sequel to this video. If you enjoyed this video, be sure to give it a thumbs up. If you didn't like the video, give it a thumbs down. If you have any questions, leave that in the comments. And if you want to personally contact me, contact this email. Until next time, goodbye.